Hi guys, this video is to go over the chemical reactions visual lab, and so we're not going to go through the whole thing together. For example, our pre-lab, there is a video I already made that goes over 4 possible clues or signs that a chemical reaction has occurred, so watch that, which will help you answer the pre-lab. And all of this you can do on your own. Just make sure you follow the links and you read the directions carefully. What I do want to go over in this video are some of the more maybe difficult sections of this lab. So the first one, this is this third page. We have to record your observations from the lab below and complete each chemical equation by listing the chemical or the correct chemical formula for each of the products. So this handout is dealing specifically with single replacement reactions and double replacement reactions. Okay, so if you need a review of those, I would go to the previous week. There's a video explaining there's 5 types of chemical reactions that we can kind of identify that will help us predict the products with the reactants given to us. So single replacement, that's always when we have some type of molecule, and here we'll just use some letters as an analogy. In a single replacement, our C is going to kick out A. One is replacing the other, to where our products are going to be kind of reversed to a degree. So for example, if we look at the first problem, we have copper sulfate plus zinc. This is a single replacement reaction, right? And what happens is the zinc, which is a metal, is going to replace copper, the other metal. Metal will always replace metal, okay? So you always want to make sure the metal is going in the front of the reaction, to where we get zinc sulfate plus copper, which is now on its own and going to exist as a solid. All right, this is a single replacement. Same thing for the next one. Here we have AgNO3, silver nitrate, plus copper on its own. Go ahead and the copper is going to bump out the silver to where we get copper nitrate plus silver, which is now on its own. All right, so now if we look at the next few, we can see that they look a little bit different from single replacements. These are double replacement reactions. This is where we have 2 molecules with 2 different elements in each one, and this is where basically the metals still replace each other. So if we have AB plus CD as our analogy, we then get CB plus AD. All right, all I did was switch the A and the C with each other. Okay. So once we see that, we can just see the sodium and the silver, they're going to replace each other. So we get sodium nitrate plus silver, oops, get rid of that. Silver chloride. And then we'll do one more and then we'll move on. So same idea, silver nitrate and sodium bromide. These metals are replacing each other, double replacement. So again, we have sodium nitrate plus silver bromide. So what you're going to do, take a look at these links. They'll tell you, they will show you what these chemical reactions will look like with the naked eye, and you'll record your observations here. All right, and you can do the last one on your own. All right, moving on. So we have to kind of identify the type of reactions that take place, and then from that, we can get the products that we see here. So one more thing I want to go over, just make sure you answer all of this as well. The quiz, we want to make sure in preparation for the quiz that's going to be this week, check Canvas for the exact date. It might not actually be Friday, so just check your Canvas for that. But we need to be able to balance chemical equations. So there's a video where I going over some of those examples. Remember where we kind of created 2 sides with reactants on one and products on the other. So if you need a tutorial or you need help with that, I would definitely advise going to that. This is some more review and practice with balancing chemical equations. So we're going to go over a few together. And in this video, we're going to actually kind of group things together. Because if we look at this equation for number 1 that we have to balance, we see OH on the left and OH on the right. So instead of just individually counting how many oxygens and how many hydrogens we have on each side, we can actually just kind of skip a step and just count how many hydroxide, or OH, ions we have on each side. So on the left, for example, we have 2, right, because we have that subscript on the outside of the parentheses. And on the right, we have only 1. So the first thing we can do is just add that 2 right away, right? So that'll change the OH to 2. Now we have 2 sodium, right? And we only have 1 sodium on the left side here, on the reactant side. So we can go ahead and add a 2 coefficient here. That'll balance out the sodium, and we now have 2 bromide as well, right? And if we go over here, we can see that checks out or balances well with that. So the last one we'll check is calcium. We have 1 calcium on the left and 1 calcium on the right. So this is good. We are balanced here. So we can just go ahead and fill these in as 1s because those aren't going to change. And then if we look at it, we have to decide what type of reaction it is. Well, we have this OH molecule here, or this calcium solid here, bumping out sodium. So this is a double replacement. Just put DR. All right, moving on to the next one. We have NH3 plus hydrosulfuric acid plus ammonia plus sulfate. Okay, so to do the type of reactions first, we can see we have 2 molecules here and form 1 at the end. This is going to be a synthesis reaction, right, where we are adding 2 things up to get 1 bigger molecule. All right, now to balance it, we can't do the exact thing that we did in the previous one with NH3 because we have NH4 on the product side. Okay, so, but what we can do is if we look, we have SO4 on the right, SO4 on the left. So we can kind of just think of those as 1 molecule or 1 substance. We have 1 on both sides. All right, next we want to count how many nitrogens and how many hydrogens we have. So if we look on the product side, we have a 2 subscript on the outside, and that's where we distribute, kind of like in math, as to where we times that 2 by each individual element. So we have 2 nitrogens, right, 2 times 1, and then we have 2 times H4. That'll make 8 hydrogens. Looking on the left side, we have 1 nitrogen and 3 hydrogens here and 2 hydrogens here. So we have 5 hydrogens. Well, the first thing we can do that I see, just looking at this, we have 2 nitrogens here, 1 nitrogen here. That's something we can easily balance out by placing a 2 coefficient in front of here, to where if we redo these numbers, we still have 1 sulfate. And now we have 2 nitrogens, and 2 times 6, or 2 times 3 is 6. 6 plus 2, that's 8. And if we look at that, now look at that, it's balanced. So that kind of helped put all the pieces together. So then we could just go ahead and put 1 as a coefficient for the other 2. All right, so that was just a little review. Make sure you are comfortable balancing equations before you start taking the quiz. Make sure you understand the clues for chemical changes as well. Watch that video if you need an extra hand. And I will talk to you guys later.